All right, everybody. So at this point, you should be very confident with how to do GCF factoring. And today we're going to talk about grouping. So factoring by grouping means that we're going to be taking four terms and we're going to use a technique called factoring by grouping where we group the terms into two groups and factor each group separately. And if you do it properly, and if I set the question up right, you're going to wind up with two brackets that match, and it's going to be a GCF question just like before. So for example, if I wanted to factor these four terms, there's no GCF for all four of them. But what we instead do is we're going to break it up into two pairs. Okay, so at the beginning, we're always going to just pair the first pair together and the second pair together and look for a GCF that matches each of those pairs. All right, so in the first pair, you have a common factor of x squared. In the second pair, you have a common factor of 3. Notice, by the way, the plus sign that gets carried down underneath, because that's going to be important when we put the pieces together at the end. Notice we have a common bracket. This tells you you're on the right track. So what happens next? Well, as I said, this plus sign is going to be important, but now we have a question you're used to with a GCF that is a binomial x minus 7. So let's see the animations. The x minus 7s are going to move out to the front, and the x squared and plus 3 that are left behind are going to move into the leftover bracket, which we've seen a few times. So that means that this four-term polynomial, x cubed minus 7x squared plus 3x minus 21, is equal to the product of x minus 7 and x squared plus 3. And if you FOIL it out, you'll be able to check that it's really true. X cubed plus 3x minus 7x squared minus 21. You'll also see that you kind of have to reorder the terms, right? So to see if they match exact. Okay, so let's go on to this question. Now that you've seen it worked out, you're going to pair up the first and second and the third and fourth. You're going to factor out a GCF. In the first pair, you can factor out a 3x squared. In the second one, be careful, you're going to factor out a negative 5. So notice that the sign for that, where the negative 45 was, has turned into a positive because you factored a negative out of that term. Our two brackets match exactly, so we throw those two x plus 9s out in the front, okay? And here comes the animation. 2x plus 9s go out in front. 3x squared minus 5, the leftovers, go into the second bracket. Now, sometimes there's another step involved in these, okay? But for now, that's where the question ends. Here's another one. This one is a little different because we got a couple of letters in there, right? But same deal, you pair them up, the first pair and the second pair. Look for a GCF that comes out of both of them. So coming out of the 6a squared plus ab, I'm going to wind up with a times 6a plus b. Coming out of the 30a minus 5b, I'm going to wind up with negative 5 times 6a minus b. Uh-oh, what's going on here, right? The brackets aren't matching. This is a common mistake and you really have to watch for it. What I did was I forgot that when I factor out that negative 5, I got to change both of the signs in the bracket. All right, so that's going to become a plus on the b. So moving along, going to factor out the common 6a plus b and the leftovers a minus 5. Sorry, no animation this time. Okay, something weird's going to happen on this one. All right, let's take a look. When I pair them up, there's no, well, you're going to see. I'm going to take out the 3 from the first pair, and I'm going to take out a 2p from the second pair. The brackets don't really match, do they? They're close, and we've seen this before. They are reversed subtractions. So we're going to use that concept of swapposite, to turn the 2n minus m around. So basically what that means is you factor a negative out of that term, and it's going to go in the front of the 2p. And now you can just sort of rearrange the negative 2n plus m to be m minus 2n. So we'll usually do this in one step, just as you see right there. Swapposite. And now my common brackets go out in front, and my leftovers 3 minus 2p of the second part. All right, and there's that reminder, okay, this is why that change of subtraction will always work. Okay, next complication. Watch out for this. I got my 4 terms. I take out the 2 from the first pair. I take away the m from the second pair. And my 2 brackets don't even look a little bit the same, right? There's no common bracket factor. And so at this point, you're going to panic a little bit maybe. You didn't make a mistake. But the strategy here is we're going to have to reorder the terms before we end up doing the factoring. So check this out. I'm going to order the terms, and the safest way of doing this is in descending order of exponents, all right? See the m cubed, m squared, then m. I'm going to take out an m squared from the first pair, and I'm going to take out a 4 from the second pair. And I know I'm on the right track now because both brackets are going to match. Once you have the matching brackets, that pair, or at least comes a single bracket out in front, and the leftovers in the second bracket. With a little more practice, you guys are going to get the hang of this, but hopefully this makes enough sense to you and we can practice some examples. All right, good luck with that.